Okay, good morning, good morning, good morning. Oh, I forgot to write the date. Oh man, I forgot to write the date. So the date is I did make this promise. So today's date is June 17 of 2025, right? Yeah. And today I made a promise that there are certain questions that I would do, and this is one of them. Now, funny, I'm supposed to start at 12. But I don't know. You know, when you feel lazy and you need to kind of keep yourself busy so that you can wake up, I feel like I'm having that moment, right? Kind of feel like that. Feel like I'm having that moment. Because sometimes if I don't make myself active, yeah. Um, I owe you a call. I need to call you. There's a lot that's been going on. So when I get done, I will make the attempt to call you. I'll do just that. But yeah, I need a better tablet. I need more hard drives, and I need yeah, that should solve the problem. If I have a better tablet and more hard drives, yeah, I can do what I need to do. What was the second number? What was the second number? Let me scroll through my library and get. I know what I was looking for. Wait, what? No, that's nope. Okay, so the next one. Next one is. Okay, you know what? I wonder if I can do that. Yeah. So I'm going to be doing all of that. Yeah. That's what I need to do. Well, yeah. I decided to get a head start on the day, cause yeah, my feel a little bit too lazy today. So I might just marathon run it. I might just marathon run this. I really just might do that. Maybe this is what I'm supposed to do. I don't know. Maybe I should be up earlier, because then I could do something else later on, but it's fine. Alright, so yeah, might as well get some of this started. Yeah, so fraction here, whole number here, fraction here, whole number here. And you know what? The simple way to describe it is birds of a feather flock together. So we want the numbers together, the fractions together, right? Like if we were to say, all right, here we go. Well, obviously, I mean, this is just oversimplifying it, right? But yeah, you have fraction and number on one side, fraction and number on the other side. Let me just throw something over here. So I think though, so therefore you want to put this over here and put that over there, right? If we're trying to, add context to it, right? So we want the x over 7 beside this, and we want the 4 beside the 5, right? Yeah. I'm wondering which one is easier to do first. I mean, sure, we could add 4 to this, and we add 4 to that, right? So 4 minus 4 is 0. 0 plus 2x over 5 is just 2x over 5. That is equal to this. then we can simplify that. 5 plus 4 is 9. So we don't have to keep all of that, right? So we're trying to, cut down on the amount of work we have, right? So that is your first step. Then now I want the x over 7 to come over here. Well, if I want to get rid of it from here, I have to say, well, let me empty the account. But if I do it on the right, I have to do it over here as well. So I have to do this too. Yeah? So that's what I'll have to do. So like what we had up here, 4 minus 4 is 0. X over 7 minus x over 7, that would be 0. So therefore 0 plus 9 is just 9 on that side, right? So yeah, so we can get rid of that. We can get rid of that. And 0 plus 9 is just 9, yeah? So now what we can write is now algebraic fractions work the same way like normal fractions. The only difference is there's letters. Just like how numbers work the same, just like how you have what you call algebraic terms. So for example, 9 plus 8, birds of a feather flock together, alright? So you have that. Or if you have 9x plus 8x, then of course that gives you 17x. So if they're the same, you can add them. That's the reason why we had to move this to this side and this over here, because there's nothing we can do with this and this. It's like you speak German, I speak English. You speak German, I speak English. So English go with English, German go with German, right? Birds of a feather. Yeah? So now this is how they look in terms of just whole numbers. But let's talk about fractions then. Like what would that look like? So suppose we had, let's say 2 over 5 plus 3 over 7. Well, obviously you find your LCM and all of that. Fine. But if you had 2 over 5 x plus 3 over 7 x, then again you have a similar situation, but obviously it's the same answer with the letter x beside it, right? And that's a weird thing about algebraic fractions. It's like you can, how it looks depends on what you do with it, because this could be called 2 over 5 with x beside it and 1 over 7 with x beside it. You can look at it like that as well, right? So just so that that makes sense, right? Let me try and make that make sense. You have 2 over 5 with an x beside it, or a 1 over 7 with an x beside it. Because what really happened here is that if you multiply x by 2, you get 2x up here over 5. X times 1, x up here over 7. So, yeah, these are similar things. They just look different. right? And that's the thing with maths. Like sometimes you will look at something and say, but no one can do it like this, you know. So it depends on what works better for you or what makes you more comfortable, right? So anyway, long story short, how we deal with normal fractions is the same way we deal with algebra fractions, right? Watch this now. 5 and 7, both numbers are prime. And the good thing about prime numbers is that once the majority of the denominators are prime, you multiply everything you see. So you don't have to worry about, let's say, 10 and 16. If you have 10 and 16, they are composite numbers. If the majority is composite now you have to start doing your little, shuffling. You have to start saying, okay, well, how do I get the LCM of those two numbers that are not prime? But in this case, because it's prime, you multiply 7 by 5. Yeah? You multiply 7 by 5. So we're not stressed out with ourselves. Right? No, they could have made it a little bit more difficult by giving us, let's say, they gave us like 8 and 12. They gave us 8 and 12, we'd have to figure out that. Right? But this is different. 5 times 7. But if you multiply this by 7, you have to multiply that by 7 too. Because you don't want it to be a different number. But if you multiply 5 by 7, you have to multiply 7 by 5. So you multiply this by 5 and this by 5. So, the aim of it is so that we'll go from it being 5 and it being 7 to them both being 35. And again, if we want to translate that, this person attack English, this person attack Portuguese, but now the two of we talk the same language, right? Either both of us Portuguese or both of us English, right? Just for context. Now the top number now, 7 times 2, 14, and then 14 beside the x, so we'll have 14 x right there. Alright, hold on. Let me use a different color so we don't confuse the issue, Alright. So I'll put 14x right there, Alright. What's this one? 5 times x. There we go. And then of course nothing of hold on there. Yeah, I'm almost writing a blue while ago. Yeah, so this over here is just our 9. What else? Okay, fine. Okay, alright. So obviously 14 minus 5 is 9, right? So now you're going to have 9x, and all of that is over 35, and that is going to be equal to 9. Now again, this is why the way how it looks is important, because what is really happening is you're multiplying 9 over 35 times x. Now that's important, because this is your coefficient. This is what is in front of x. So if you can actually see that, then it's easier for you to figure out how you're going to get this away from the x. Now is a fraction. And anytime you want to get rid of a fraction, you multiply that fraction by the reciprocal of this. So you go flip this upside down and multiply it by this. So we're going to flip it upside down. This is going to be 35 over 9. But again, what we do to the left, we do to the right. So this is going to be multiplied by 35 over 9. And what? You find the HCF. When you find the HCF, obviously, you have a 9 up here and a 9 down here. 9 over 9 is 1. 35 up here, 35 down here. That over that is 1. 1 times x is just x. Right? So therefore, yeah. Then over here, life nice because 9 over 9 is 1. And 1 times 35 is 35. So if we rub out everything, we draw a line through, right? So that's equal to 1 times x. And 1 times x is just x. And then if we get rid of this here, then what we have here? What we have here is what we have here is 35. Now the good thing about this is that if you were to put this up here or over there, we should get the same answer on the left and the right. So 35 over 5, that is 7. 7 times 2, that is 14. 14 minus 4, that is 10. So that means that the left side is 10. Try it again. 35 over 7 is 5. 5 plus 5 is 10. 10 equal 10. Right? So the answer must be this. Because when you substitute 35, the left is 10, the right is 10. Alright? So maybe what I can do, I can I will, maybe that's what I need to do. Maybe for each one of these I will we have solution and we have proof, so we can actually prove that work. Alright? So we can do that next time. Sorry. So now let's move on to our next question. Now it is what? X minus 4 over 3. Is that minus or plus? Plus, okay. X plus 1 over 2, and that's equal to that's equal to 20. So this is, yeah. All right. 2 and 3, again, both numbers are prime, right? Now, what some people do is what they call the butterfly, right? Or you can just cross multiply. Take this 2, multiply it by x minus 4, and take this 3 and multiply it by, x plus 1. But at the same time, if you're going to be doing that, it means that you multiplied this by 6, this by 6, and that by 6 as well, right? So what you really did was you multiplied everything by 6. Alright? So if you multiply, alright, let me move this so that we don't get confused. Alright, so yeah, I'm gonna put this up here. So if you multiplied this by 6 you end up with 2 anyway, right? So you might as well take the 2 and just put in front of here, right? 6 over 3, give it a 2, 2 times this. So if we left it as it was and multiply it by that, then yeah, you'll end up with the same thing. So again, then you have 6 times this, which would again be x plus 1 times the 3. And then of course, if you do that here, you have to do that here. Alright, so with that now, as you would predict, this times that, that times this, yeah. And then this now, this is not so bad, right? 2 times x, 2x. 2 times 4, 8. So you have 2x minus 8. So you have that. 3 times x, 3x. 3 times 1 is 3. There we have that. Now again, we'll come back to what? Birds of a feather, right? This is what we call grouping like terms. So we have, you know, what we can call it PlayStation and PlayStation, Xbox and Xbox, alright? Something like that. Yeah? Or, you know, it could have been anything. CD and CD, DVD and DVD, whatever. Alright? So, if you have 2, whether it is 2 pencil and 3 pencil, in total you have 5 pencil. Right? So 2x plus 3x will be 5x. Right? So we can just rearrange it so that it makes sense, or we can just do it visually if we understand. Now, this is just straight up integers, right? So if I owe you $8, but I give you 3, how much left do I have to give you? 5. So if I have $5 left to give you, it is minus 5. Because I'm going to be losing that $5. I'm not gaining it, I'm going to be losing it. So that's why it's going to be a negative 5. Right? So the minus 8 plus 3 is going to be a minus 5. And the 2x plus 3x is going to be 5x. Right. Now, I mean, my favorite thing to do here, there are two options. You can add 5 to both sides, which give you 5x equal 125. Right? But I mean, when the numbers end with 5, it's a no-brainer at this point, right? It really is. In fact, you could almost divide all of this by 5. You really could. Let's see. 120. 120 is what? 12 times 10. And 12 times 10 is the same as 24 times 5. Yeah. And we can pull this out here, right? Let's say we were to factorize it, right? 5 here, 5 here. If we divide this by 5, we get x. We divide this by 5, we get that. Right? And then that is equal to what? Call it 24 times 5. Then now you can divide both sides by 5. So if you divide this by 5 and this by 5, right, what you end up with? You end up with x minus 1 is equal to what? Now I believe that's a lot easier to look for. Right? This is easier to look for. I mean, we could have done this another way. Right, I can show you the other way. Now, if you add 1 to both sides, x is equal to 25, your answer is 25. Right? Okay. Let's do it the other way. Let's see what that looks like. What does that look like? Alright, what does it look like? So there are 3 ways to do this. 3 ways. So again, we could do what we normally do. Add 5 to both sides, resulting in what? 5x equal 125. And then all we do, we divide both sides by 5 and we still get our answer. So the next line would still be x is equal to 25. So we're still going to get that answer. So that's the other way of doing it. Another way of doing it, again, is probably for the more, I guess the more difficult questions or the more challenging questions. Watch this. Sorry. Yeah. Yeah. Why did I do that? Why did I do that? Why did I get rid of that? Okay. Imagine you have this. So, if you had a box that had some things in there, and when you take 5 things out of the box, when you count inside the box have 120 of them. So how much was it originally if you take 5 out of it and you're left with 120? It means that if you put back 5 things back in the box, you end up with what? 125. Therefore, 5x is equal to 125. What I like about this is that this makes this line true and it makes this line true as well. So we couldn't put 120 in here because that would be wrong. 120 minus 5 is not 120, right? Or 115 minus 5 is not 120. So the number that goes here has to be correct. So if we do this, we must end up with that number over there. And then we just write 5x equal 125, and then we go through the process that we did before, where we divide both sides by 5, right? So we'd still end up doing the 5x equal 125, and then we divide both sides by 5. Yeah, so we've done enough of it, enough of this. Yeah, we do quite enough of it. Yeah, I guess I was surprised at how easy that one turned out to be. And it's weird. Okay, I'll give you a perfect example. You see, if it was just this, let's say if it was just like now, if there's no equal sign, you're doing something completely different now. What you're going to try and do is make this a single fraction. But once you have an equal sign, now you're trying to find the value of x. So therefore, there are 2 things that happens. If this is by itself, you're creating a singular fraction with one denominator. So the LCM of 2 and 3 is 6. So we know that down here has to be 6. Right? And Some people use the, what you call it? The butterfly. So whether them wanted this thing and this thing, some people do that. Right? So therefore, you take that 2, put in front of that right there, the 3 in front of that right there, and all of that over what? 3 times 2. Or you can just say 6. Like, who are we fooling? Right? So we done this up. It works out to be the same. It works out to be the same. Because if I multiply this, yeah, you know, it's invariably the same thing. Because if I put 6 out here and I divide 6 by 3, I'll have 2 multiplied by this over the 6. Or I mean, it's only four ways to look at it. Because you could say that this was originally 1 over 3 times x minus 4. You could have said that. And if you wanted the 3 to become 6, you multiply this by 2 and that by 2. Why did I use the wrong color a while ago? So multiply this by 2 and this by 2. So therefore, 1 by 2, I have the 2 here. 3 by 2, I have the 6 here. So 2 over 6 times the x minus 4. Alright? And then we also have the 1 over 2 times x plus 5. One over 2 times x plus 5. So we have that. 1 times the 3, give it that. 2 times the 3, give it that. Yeah. So now, the distributive property time, the easiest thing to do is just take your time with it. So 2 times x, you just write 2x. Then 2 times 4. Some people write it out. But you know, sometimes you can get confused because the minus sign is in the way and that sort of thing. Yeah, that can get messy. Especially if you have something like this. That can get messy. Yeah? The minus signs are the ones that you need to look out for. If we're talking about anything that make life or mathematics more challenging and, you know, a bit of a conflict, having a minus sign out here, yeah. And think of the minus sign as bad mind. Were you once positive? Not anymore. Were you once negative? Not anymore. So the negativity changes you, right? So if you use a positive, too bad. You're not positive again. If you're a negative, not enough space in this town for both of us. So it's like the sheriff versus the outlaw. Yeah, 2 bad men can't be in one place, right? Something like that. But again, that is in the context that there's a minus sign out here, right? But then, when it's positive, I accept you as you are. So if I multiply a positive by a positive, you stay that way. If I multiply a positive by a negative, you stay that way. Right? So that's the difference between positive and the negative. When I'm positive, I leave you as you are. So a positive times a positive, you stay positive. A positive times a negative, you stay negative because I accept you as you are. I am not changing you. Right? Then no, the negative sign, no. You can't, this unacceptable. You're positive? No, not today. Then them see you're negative, they say no, not today. Anyway, so 2 times x, we have the 2x. 2 times 4, we have the 8. And then 3 times x, we have the 3x. And then, of course, this will be, yeah, all of that over the singular 6. And remember, birds of a feather flock together. I always, when I'm grouping like terms, this is what I say. Imagine this is you, the person beside you is not your friend, this is your friend, and this person wants to be beside their friend. You want to shuffle them around so that the friend them are beside each other. You don't want them on a bus and you are here, this is your woman, and somebody in the middle of you and your woman. That don't make no sense. That makes no sense. Or if it's your family, you know, this is you, this is your child, this is somebody in between, a complete stranger. That, again, that don't make no sense. That don't make sense. So, birds of a feather flock together. Right? So, you know, we can have them switch. Right? Make them switch seats. But when you're switching seats, what you have to do? You have to move your luggage as well. This is the luggage that belongs to 8. So when 8 move over here, he have to go carry the negative sign with him. And this is your bag. Remember, say it upon bus or whether it's Knutsford or JetBlue or Spirit or whatever. Yeah? You have to go carry yours. So when we switch it around, we had -8 and plus 3x, right? So let's switch them around. Again, we had a plus 3x, so you carry your bag. You had a -8, you carry your luggage. And now, the birds of the feather, yeah? Can flock together. And now finally, you have 2x plus 3x, resulting in what? Let me just make sure some have a little more space than that. Alright, so we have 5x plus 7 there we go. So the aim of when two algebraic fractions are added together is to create the single fraction, right? That's really what that's really what you're trying to do. Yeah. Now, if it happens to be equal to some number, now you're actually looking for the value of x. So if you make this equal to something, you're looking for the value of x. But if there's nothing that is equal to, and then this used to confuse me. Okay, it used to confuse me. Now watch a joke. The entire thing becomes different. So let me write it again. What if I had x minus 4 over 3, x plus 5 over 2, but it was that instead? You see, what end up happening now is that now again we're trying to find the value of x. So in other words, this right here with the equal sign in between is different from this right here with the plus sign in between. Right? So yeah, I used to get confused by this. I used to wonder, when do I make it a singular fraction and when do I try to solve for x? You solve for x when there is an equal sign. So if you want to simplify it, yeah, when there's an equal sign, we're trying to find x. But But when it's a plus and there's nothing else, no equal sign in sight, then we're just trying to make it what? Simplify it to one algebraic fraction, right? So I am explaining that because that used to confuse me. Yeah? So I can speak to that. So let me go to number 3, because I did promise to go through all of it. Let me see how quickly I can get through all of them. And it's enough. Let me see. Tablet don't fail me. Oh, yeah, my tablet is about to. Might have forgot to charge it. Oh no. Oh no, that's not good at all. Alright, what's the next one? Alright, this one, okay. So this one's kinda crazy. Let's look at it. So it says 5x over 3 plus okay. You know, so I should have put these on my computer instead. What have I done? And maybe I can do that, you know. Maybe I can do that. Let's see if I can, you know, salvage this situation here. Right? Alright. What? Oh, yeah. Okay. So this is number 3. This is number 3. Let me put that up here. Number 3. Alright. Birds of a feather flock together. We want whole numbers with whole numbers and the fractions with fractions. Right? That's what we want to do. So, Lord. Dear God. Alright. So, to make this life easier, let's add 2x over 5 on the right. But if we do it on the right, it must also happen on the left. Right? And if we're being quite literal, I owe you this amount of money. If I give it to you, I have nothing left to give you. So 2x minus 5 minus 2x over 5. 2x over 5. Let me say that properly. 2x over 5. 2x over 5 minus 2x over 5. Yeah. You do that. Yeah. Alright. Equal and opposite forces, right? Yeah. So, we're done with that. We're done with all of that. So now we'll have so let me rewrite it now. Let me rewrite it. But then this is, yeah. And then there's one more thing now, because these are fractions, but you need to be with your squad. So I got to take myself away, right? You have to take away yourself. This is self, this is, yeah, you have to take away yourself. So the minus 4 on the left, and you, sorry, and the minus 4 on the right. Lord God. Alright. Okay, so 4 minus 4, 0. 0 plus this, right, is just that. So we'll have this. And that is just yeah. 3 and 5. Again, these numbers are prime. So we know what to do. Multiply this and this by 5, this and this by 3. Right? Yeah. I mean, isn't there another way? I'm sure there's another way. I mean, you could have do it like that, you know. You could. I mean, you could multiply the left and the right by 15. Right? Because if you multiply the left and the right by 15, 15 over 3, you get 5 same way. Multiply by that. Yeah. But, I don't know. Let me not complicate it like that yet. So again, let's multiply this by 5. This by 5. This by 3. This by 3. So now we have 25x up top and 6x up top, right? So, you know what? Both of them are 15 anyway. So let's not waste any time. This is 25x over here. This is 6x over here. I see. Alright, now up top 25 plus 6, we are going to have 31x over 15. Alright, we'll have 31x over 15. Now, that's the beauty of doing this. The inverse of this is what? 15 over 31. So why don't we multiply this by 15 over 31? But if we do that over here, we must also do that over here. Now I know that 31 times 3 is 93. So I can divide this 31 by 31. I get 1. Divide this by 31. I'll have 3. So on the right, I'll have 3 times 15. Therefore, this will be, that will be 45. And then, of course, that is 1. Yeah. 1 times x, leave us with just x. Now, the real question is, does this actually make sense? Does it work? We'll see. 45 over 3 is 15. 15 times 5. Hold on. Lies. Hold on. I just remembered. It's supposed to be equal to what? To 93. So we make sure that everything come out the way it's supposed to. Alright? Oh, wait. What was it before? Let me look on my tablet. It was... What was that? Oh, yeah, right. Okay, I forgot. I forgot. It's supposed to be equal to this. Yeah, that was the original. So that's why it looked weird to me. Yeah. Yeah, okay. So I'm trying to go back to the original so that I can make sense of it. Alright, so 45 over 5, right? That is 9. 9 times 2, 18. So 97 minus the 18 It's going to be 97 minus 17. 80 minus 1, that's 79. Good. Yes, both of them are equal to 79, right? So therefore, when you do this, you get 79. Right? Then the 45 come over here. 45 over 3. 15 times 5, 75. 75 plus 4. Yeah. So both sides are equal to 79 when you substitute the 45. Yeah. Now, mind you, if I wanted to do it, how would I have done it? I mean, any other way? No, any other way would have just been what we just proved. 45 over this 15 would have been 3 times that. You'd have get 93 anyway. So yeah. Okay. What if I wanted to do it from here? Would that have worked? 45 over this 3. This would have been 75. Alright. Then this 45 over 5. 9 times 2. 18. 18 plus the 75. Yeah. 93. Yeah. Right. So what was missing from here was, yeah, the 2x 2x over 5. It's just that because I forgot that I had gotten rid of it by doing this. I add 2x over 5 to here and here, right? But I wanted to go back to the original so we can see if, when we substitute this 45, what value we get on each side. Alright, so that takes care of this question here. So left is equal to 79, right is equal to 79 too. Let me see what else is there. Oh, alright, number 4, 36 over x. This one not gonna take long. This one not gonna take long. It's not gonna take long. Because sometimes it's how they look. Right? Sometimes looks are deceiving. So let's see. So we have 36 over x. And then that's equal to this right here. Yeah. Alright. Again, birds of a feather flock together. Let's add 5 to both sides. You end up with 17 over 2x plus 5. Right? Then now, we're going to minus 17 over 2x from both sides. So once we do that now, we're now left with now the LCM of x and 2x is 2x. So we're going to multiply this by 2 and this by 2. So now that will give us 72 over 2x is equal to the 5 right there. So this will be 72 over 2x. Now we have 55 over 2x equal to 5. And again, you can call it 55 over 2 times x. So you can do that too. Because it's all about how it looks. So you could have this. Make sure that I have that properly. Then we're left with multiplying both sides by flipping it upside down. So we multiply this by 2 over 55. And then 5 over 55 is what? 1 over 11. So everything should come to x being equal to 1 over 11. Right. Question is, does this work? Does that even work? Okay. Yes, this is where it gets a little bit crazy, because if you divide 36 by 1 over 11, you get 36 times 11. Right? Okay. 360 plus 36 is 396. So 396 minus 5 is 391. Okay. Does that work? Does that indeed work? Alright, let's try the other side. 17 times 11 divided by 2. Oh, guess what I did wrong? I have 1 over 11 times 2. See? I knew I did something wrong. There you go. What am I doing? The result of this is 1 over 11. The answer for x is 2 over 11. There we go. See? That's why I have to double check your answer them, Because you can do part of it right, But the ultimate thing you get wrong because, mental maths is good. But sometimes you have to write things down. Write it down. Alright, good. So that means I can get rid of that crap right there. Because that don't make no sense. So it's 2 over 11. Right. So it would have been 396 divided by 2. See it there? Alright, I'll go do it quick. I do. 396 over 2. We have 1 here. Then 19. Then 16. Alright, so you have 198. Right? So let's do that again. Yeah, 198. Alright, so therefore the left is 198 minus 5, resulting in 193. That's what the left should be. Okay, now let's go over to the right now. This is still kind of weird to me. Still kind of weird. Why come out like that? You see, it's that 17 throwing me off. Okay, fine. 17 by 11 is 187. Yeah, I don't know why I come out like that. I genuinely do not know. Hold on. 55 over 2x equals 5. What else was it going to be? 2x equal 11. Oh, hold on. Why is this thing doing that to me right now? I don't need this happening right now. Alright, the puzzle is throwing me off. Why is it doing that? It's not even coming up. Yeah, so they're trying to give me the puzzle to prove I'm human, and it's not showing me. And then it's not allowing me to do anything else. Come on, no. Yeah, I can't be bothered. Because normally it just come up and asks you to start. Oh, God. That's just great. That's great. Alright, let me start this over. Damn, man, that was a bit much, right? That I almost broke my phone. Almost broke my phone, man. Dear God. All right. So let me try this again. Yeah, 55 over 2x. Alright, no, hold on. Let me go back. Let me do it the way that I normally do this and see what would have been different if I did it the other way. So for example, you have 55 over 2x is equal to 5. So it would have been 2x is equal to what? Okay. Anyway, so we'd swap them, right? 2x would be equal to 55 over 5. Right? That's what that would be. 2x is equal to 55 over 5. So it would have been 11 over 2. Yeah, I don't know why. Yeah, I had it as something different. So I'm going to have to do that again from the other perspective and see how I should have ended up with 11 over 2. Right? Yeah, that's miraculous. I'm surprised my phone is not completely destroyed. Okay. 11 over 2. Does that even work? Okay. 72 over 11 minus 55 over 11. And then you have 34 divided by 22. Alright, so if I had 30, oh Lord, no, no. I don't even have life in that. So if I have 34 over 22 versus this over here, where if it was 72 over 11 minus that, 72 minus 55 would have been 17. Okay, yeah. Yeah, both of them would have been right. Okay, yeah. So the mistake I made was I called it over 11. So I'll have to do that again and see. 55 over 2x. Five over 2. Yeah. Anyway, I fixed that. Let me close this now and come back.